All right, so yesterday we started talking about continuity and discontinuity, right?
Yes.
Talked about three types of discontinuity. What were they? There was jump that only occurs in what? Piecewise functions. Then there were removable and infinite. Removable is when you have a whole, and infinite is when you have a... Yeah, remember that stuff, right? All right, so now when we do this, let's look at this problem.
Thank you.
When I look at this particular problem, I'm trying to check to see if there's any kind of discontinuity. Discontinuity exists if when you plug in this number right here into the bottom of the equation, you get what number? 0. If you plug in -2, guess what you get? 0. If you plug in 4, guess what you get? 0. That means, and here's why you're doing this, you're getting 0 values in the denominator. What happens when you get a 0 in the denominator? It's undefined. So we need to see if we can actually remove that, or if it's always going to be present. You understand that? Because it's undefined, we're going to have a discontinuity. We need to see if it's removable or if it's always going to be present, which is infinite. So here's what we do. What do we do first again? Factor it. So the top factor is how? Thank you. So x plus 2, x minus 5. The bottom factor is how? So x plus 2, x minus 4. And if you look at this, you can see that when you plug in -2 to the bottom, what's -2 plus 2?
0.
And that's 0 times this, which makes the bottom what? 0, right? If you plug in 4, what's 4 minus 4?
0.
So when you plug in that, it'll make this bottom 0 as well. Does everybody understand that? So that's why you're looking at these values in particular, all right? So we're going to cancel out the terms that are common to the top and bottom. And we're left with this. This is f of x equal to x minus 5 over x minus 4. Now we try to go back and reevaluate this, all right? So we go back and say, can I evaluate the function of f of -2 and get a number now? Well, when you plug in -2, you get -2 minus 5 is a -7. -2 minus 4 is a negative. So that's 7, 6. Since you get a value, this is a what? That's a whole. You have a whole at the point -2, 7, 6. And because it's a whole, what kind of discontinuity do you have? Removable. So if you were taking a quiz today, this is what you would have saw. Y'all got that? Now, the other one is going to be evaluate f of 4. When I plug in 4, what do I get there? At the top is -1. The bottom is what, though? Which means that's undefined, right? When something's undefined, what do you have there? Infinite, because it's an asymptote, right? It means you get an asymptote. This is infinite discontinuity. So again, there are three types of discontinuity. They are jump, which only occurs in a piecewise. Removable, which is when you have a whole, and infinite when you have an asymptote. Y'all got that? Today we're going to talk about what we call end behavior. And when I talk about end behavior, I'm talking about the tail behavior of a graph. I want to know the tail behavior of a graph. And so every function is going to have two tails. You got that? Every function graph is going to have two tails. I want to know what are the two tails doing as when two things occur. And here's what I want to know. We're going to look at it from an example. Let's look at it like this. Take this function here. You know what this function is, right? What is this function? It's just a, what's the shape of the function? Parabola. It's a quadratic, right? Everybody understand that? So what I want to know is this. As your x values get really small, and here's what I'm interested in. I want to know as x values get really small. They're really small on this side. So here's the small side. Or that's the left side of the graph, right? What is the left side? As the x values get really small, what else is really small? What number represents really small? So as the x values go to negative infinity, I want to know what is happening to the y values, or what is happening to the function f of x right here. Everybody understand that? So as the values get really small on the left, what happens to y here? It's getting really what? It's getting really tall or really big, which means it's going to what? It's increasing to what number? Infinity. Does everybody see that? What kind of infinity? It's positive infinity because the y value is getting really big, right? And as the x values get really big, which is on the right-hand side, and what does really big mean? Positive infinity. So as the x values get really big and go to positive infinity, I also want to know what are the y values doing on this side. They're also doing what there? Going to positive infinity. Alright, do you understand that? We're going to write this in what we call a limit. So we're going to develop limit notation which says this. The limit of f of x as x approaches. That's what this means. What else does f of x represent again? So I'm saying the limit of the y values as the x values approach either a really big number or a really small number is equal to what? This is limit notation. You're going to write two limits. You're going to write one for the really small values and one for the really big numbers. Alright? So here's an example. Take this function here, which is basically y equals x cubed. And I want to know what is the limit of this function. So what is the limit of f of x? Alright, the limit of f of x as the x values get really small. So how do you write really small again? And which way is really small going to be? To the left, right? So if the x's go to the left, where is your graph going here? Down. So what does that mean it's going to? Negative infinity. And then I also want to ask the question, the limit of f of x as x gets really big. It's going to what? So really big means to the right, and as it goes to the right, the graph is going up, so that's to positive infinity. Do we understand that concept of what you're doing here? You're just reading the graph now, left to right. So, try this one. Write the limit of this function, or the end behavior, using the end behavior. And again, you're always writing two limits. So you're going to write one to the left and one to the right. So the limit of the function as x approaches on the left-hand side, which is negative infinity. What is that equal to here? The function's going where? Down to negative infinity, right? And the limit of the function as x approaches positive infinity. Where's the limit going now? Where's the function going now? Down again. So there's one more, and we're going to do it like, it's going to be for this type of graph though. So if we look at this graph, and we try to write the limit, it's a little bit different. So far, both the graphs you've written the limits for, they've had arrows that either went all the way up or all the way down, right? Well, these are actually telling off at a specific number. Does everybody see that? If you look at this graph from the right-hand side, from the left-hand side, so the limit of the function as x goes to negative infinity. So if you look at this graph is doing this. It's approaching a certain value. And it wants to touch that value, but it can't because it's at a what? Because it's at an asymptote, right? So this asymptote is actually is forcing the function to stop at its particular value. What is it trying to touch? Where is it going to? What value does it want to go to? It's not going to infinity. Is it going all the way up? What's limiting it? What is it limited to? 1. So this is equal to 1. And the limit of f of x as x approaches positive infinity. So if you look at the right hand side, well, it's also, if it could go all the way down, it would, right? But it's actually being forced to stop at what? 1. It's being forced to stop at 1. So here's what happens. This is called a rational function. When you have a rational function, your limit will always be a number. When you have a rational function, your limit will always be a number. So when you see graphs like this, look for a number to give it as a limit, all right? Are there any questions on how to read the graphs? Y'all okay with reading it? Let's do limits from an equation standpoint then. So the leading coefficient, let's talk about that. And in these graphs, here's what's going to happen. The leading coefficient is the term, with the highest exponent. And realize it's a term, so it's the entire term with the highest exponent. So an example would be f of x is equal to 2x squared minus 3x to the fourth plus 1. When I look at this equation, I want the term with the highest exponent. What is the actual term with the highest exponent? Negative 3x to the fourth. I want the entire term. Do you understand that? Because what can happen now is if I know this first term, I know what the highest exponent is, and if I know the sign of the term, I can tell you the end behavior of the graph. I can tell you what the tails are doing. So here's another example. F of x is equal to 2x to the fifth minus 7x cubed plus 3x minus 1. What is the leading coefficient? What is the leading term? Or what's the highest exponent? 2x to the fifth, right? So here's what's going to happen. Because you can find leading coefficients now, you should be able to tell me the end behavior of the graph. And the end behavior of the graph is going to be based off of this right here. Your leading coefficient term can be one of 4 things. The term in the front can either be negative or it can be positive. Do y'all see that? So the term in the front can either be a positive number or a negative number. The exponent can either be even or odd. So it can either be odd or an even exponent. That's the only 2 cases. Your terms can either be positive or negative, or your exponents can be odd or even. Do you understand that? So what's going to happen is this. Every graph that has a positive term in the front and an odd exponent that leads it looks exactly the same way. They all look exactly the same with respect to their tails. So if we can remember one graph that is a positive odd, we know what every graph that is positive odd looks like. So what I want you to do is give me a graph that is that has a positive first term, and an odd exponent. And you know what it looks like. Give me one. Okay. Say it again. What does that cube look like? Everybody know what that looks like? Everybody knows what it looks like? And it goes, which way does it go? This way? This way? Y'all remember which way it goes? How about this one? What if I said, so if I said y is equal to, x cubed is a good one, but do you remember what it looks like all the time? I get confused sometimes. I forget.
Is that the one where you can, it's the two curved lines?
Is it? I'm asking, is it? I want you to pick one that you know. How about this one? Do you know what y equals x look like? What does y equal x look like? It's a line that goes just like this. We all know what y equals x look like, right? That's something. Is it a positive? Is it positive in the front? Is it an odd? Is it an odd exponent? So we have a positive odd graph that we know for sure, right?
Yes. X cubed is
the one that does this. You're right. So x cubed looks like this. If I want to graph f of x equals x cubed does this. More important, look at the tail behavior of x cubed, though. It's the same tail behavior of what? Y equals x. It starts how? How does y equals x start? On the left-hand side, it starts down, negative infinity, and it finishes how? Up. Look at x cubed. X cubed starts how? Down, and it finishes how? Up. Does everybody understand that? Now, a negative odd graph, well, give me a negative odd graph that you know. If we know y equals x, we also know what? And that graph slopes just in the opposite direction, right? So how does this one start? This starts up and finishes how? Down. Positive even. Can you give me a positive even graph you know? Y equals x squared. How does this graph finish? How does the graph start and finish? Well, it starts how? Starts up and it finishes how? Up. Can you give me a negative even graph you know? Y equals negative x squared. How does that graph start? Down and it finishes how? Down. Yes. Yes. What do you notice about odd and even graphs? What do you notice about the odd compared to the even graph? Odds go in what? Opposite directions. Evens are in the same direction. Y'all understand that? Way to remember that. My wife showed me this, by the way. She wrote it like this. Odd stands for opposite. And she did this. She took the D and she put an arrow on the D like that. Took the D and put an arrow on the D like that. I thought that was so cool. Then she did this with even. Look how cool that is, right? No? I was impressed. Odd graphs go in opposite directions, even graphs go in the same direction. That's what you need to remember, right? Or if you forget that, you can just remember what? And a positive odd graph is going to be what? Y equals x. You understand that? Any positive even is y equals x squared. Negative odd is y equals negative x. Negative even is y equals negative x squared. So now from this we can we can figure out tail behavior from equations. Here's an example. Take f of x is equal to 3x to the fourth minus 2x squared plus 5x minus 6x to the fifth. When I look at this equation, I want to know what is the leading coefficient first. So what is your leading coefficient? So the leading coefficient is negative 6x to the fifth. So that makes it what kind of graph? Well, the first term, is it positive or negative? And the exponent, is it even or odd? So it's negative odd. When you think negative odd, what graph do you think of? Y equals negative x, right? So how does the graph start? Up, and it finishes down. So now, from this I can write the limit notation. From this I write the limit notation. So the limit notation says the limit of f of x. As x approaches, from the left-hand side is the first sign. What does up mean? What does up mean in terms of symbols? Positive infinity. And the limit of f of x as x approaches from the right-hand side, which is positive infinity. What does this down mean? Negative infinity. If you were to graph this, the tails would on the left-hand side would go up, the tail on the right-hand side would go down. Try this one. F of x is equal to 3 minus 4x plus 2x cubed minus 4x to the fourth. What is the leading coefficient? So negative 4x to the fourth, right? So that makes the negative 4x to the fourth, is that the sign is going to be negative, and this is a even or an odd graph? Negative even. When I think of negative even, I think of the parabola going down, right? So both my signs are going to point which way? Down. So again, it's the limit of the function as x approaches negative infinity, or to the left, is equal to, what does down mean? Negative infinity. And the limit of the function as x approaches positive infinity, or if x gets big, is equal to what? Negative infinity too. Y'all feel okay about this? Good with that? Alright, what I want you to work on now then